Hi, welcome to the Center of Math. For this week's problem of the week, we want to find this sum here, sum of 1 over product of a sum of this set. This outer sum is taking over all possible permutations of the set 1, 2, L. So if the set was 1, 2, all the possible sums would be over 1, 2, 2, 1. So let's first calculate the sum for just L equals 2. The sum becomes I'm going to call this So for L equals 2, we see sum 2 equals 1 over A1 times A2. So this might suggest a general rule that the sum SL is just, in fact, 1 over the product from 1 to L of AJ. Now, let's assume this is true for L equals N. And then let's try to find this sum for N plus 1. So we want to find this sum given that the sum for n is just 1 over the product from 1 to n of all the a's. So now let's partition this sum. Let's partition it into, so we have all these permutations. We're going to partition it into one set of permutations that, let's say, has AKN equals A1, another set where AKN plus 1 equals A1, another set AKN plus 1 equals A2, and so forth. For example, let's show this for n plus 1 equals 3. This permutation is going to look something like. So for n plus 1 equals 3, we see we have 6 different permutations. We're going to divide this up into 3 different sets, where in one set 3 is the last number, another one 2 is the last number, another one 1 is the last number. So if we do a partition like this for the general case of n plus 1, and consider just the sums for one of these sets, we'll see that First, the last term in this product is always the same. It's just the sum of all the numbers. We're going to factor that out. So we see that S prime n plus 1, or the sum for just one of these sets of our partition, is equal to 1 over the sum of from 1 to n plus 1 of AJ, so the sum of all the elements, and then the sum over all the permutations of just n elements. These n elements being every element except A of k of n plus 1. And so recall that we assumed that for Sn, we can say Sn equals 1 over product from j equals 1 to n of aj. So we can say here so we can simplify our sum of just one of the sets of our partition into 1 over the sum of all the numbers times 1 over the product of every number except A, K, n plus 1. And this we can rewrite a little bit. So we can rewrite this as 1 over the sum times akn plus 1 over the product of all the elements in our set. And note that the product of from j equals 1 to n plus 1 of ak of j is in fact equal to the product from j equals 1 to n plus 1 of just aj, because multiplication is commutative. We have all the same numbers, so these two products are equal. And so now let's sum all of our different sets of our partition. So if we sum all of our different subsums, we're going to see we can factor out this sum here. It's the same for every set. This product here, because of this, is going to be the same for every set. Now akn plus 1 will take exactly one value from our initial starting set, our a1, a2, an plus 1. So when we sum up all the different subsums, we're going to see that this sum is in fact just equal to the sum of all our numbers. And so if we cancel out these two terms, so if we simplify, we get that Sn plus 1 is equal to 1 over the product from j equals 1 to n plus 1 of aj. And this comes from assuming that Sn is a similar form. And we know this is true for n equals 2, so it's true for n equals 3, and so forth. And so it's true for all n. All right, and that's our problem of the week. Thanks for watching. Please check out censormath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.